Good morning. So today let us see the another concept which apply to drive the large capacitive loads. In previous session we have seen cascading inverters technique to drive large capacitive load in order to improve the speed. Now the another technique is using super buffers. Here the concept of the principle involved in the super buffer to increase the speed is supplying large amount of current to charge the capacitor so that the capacitor will charge very fastly so that the speed will be increased. Let us see the super buffer diagram. The super buffers structures available in two forms. One is inverting type NMOS super buffer and another one is non-inverting type NMOS super buffer. So this is the inverting type super buffer. That means inverting type means always the output is complement of the input. In case of non-inverting type, this is the diagram for the non-inverting type. Here the output is always same as the input. Okay. So let us see the explanation with reference to inverting type super buffer. So here in addition to NMOS inverter T1 T2 transistors, two more transistors are used. They act as a push pull named as transistor T3. Again it is a depletion type of MOSFET, whereas T4 is enhancement type MOSFET. See clearly the diagram. So let us see the operation, whether first of all it complements the input value or not. Suppose if the input is VDD, if the input is VDD, that means applying logic 1 value. So the transistor T2 is switched on. The transistor T2 is switched on. That means the voltage across T2 is very less. That voltage acts as a gate potential for the transistor T3. Therefore, the transistor T3 is in half state, whereas the transistor T4 is in on state because the gate of transistor T4 at the input potential only, at the input. So that both T2 and T4 are in on state and T3 acts as a open circuit. Therefore, the output is across the short circuit, across transistor T4, that is short circuited voltage, which is very less. Therefore, the output considered as logic 0. So definitely here if you observe the output, what output are getting complement of the input. What is the input value? Logic 1. What is the output value? Logic 0. Right? Let us see another condition. Now the input is logic 0. With reference to 0 input, the T2 transistor in the half mode. Half mode means it acts as an open circuit. Open circuit. Not only T2, T4 also goes to the open circuit mode. With reference to this, the gate of transistor T3 at VDD voltage, because the transistor T2 is in a open circuit. Okay. Therefore, the gate of the transistor T3 is at the VDD voltage. So high gate voltage is available for the transistor T3. Therefore, it goes to the on state. Okay. So now T3 is on, T4 is in half. Therefore, the entire VDD is available at Vout. So that voltage is considered as logic 1. So for the input logic 0, the output is logic 1. So complement output we are getting. Right? So definitely this circuit acts as an inverter. Right? But now see whether it drives large amount of current or not to drive the load capacitance. That is, without these two transistors T3, T4, the transistor T1 supplies the current for the load capacitor to charge, isn't it? Okay, in previous sessions we have seen that inverter driving the capacitive loads. Okay, so here there the current is directly proportional to VGS voltage of T1 transistor. Here how much is VGS for the T1 transistor? VGS is 0. VGS is 0. But if you come to the super buffer, the transistor T3 drives large current to charge the capacitor. Now that current is proportional to its gate potential, right? T3 gate potential. How much is the T3 gate potential? VGS VDD voltage. Okay, so since the gate voltage of transistor T3 is increased, the driving current also increases. So that is the concept involved in this super buffer. Okay, so this is the diagram work as inverting type and super buffer, whereas another model is like this. So this is called non-inverting type NMOS super buffer. Clear? Is it clear how this one improves the speed? Because it supplies more amount of current to charge the capacitor, so that it increases the speed. Okay. That current or the driving current is directly proportional to the gate voltage of transistor T3. Without T3, proportional to the gate voltage of T1. Now the gate voltage of T3 is greater than the gate voltage of T1. So that's why large current the super buffer can drive to charge the capacitor. Okay, understand? Similarly, the another technique is BiCMOS inverter technique. In BiCMOS inverter technique, it involves two types of technologies. One is CMOS technology and another one is bipolar technology. Okay, if you observe, this is the inverter diagram under BiCMOS. It includes PMOS transistors, NMOS transistors for the logic, and at the driver stage, two bipolar transistors are used, transistor Q1 and transistor Q2. Again, these two acts as a push-pull. Okay. Now let us see. Now, since the transistors, bipolar transistors, GM is very high, so that the delay is less. Okay, with reference to bipolar transistors, the transconductance value GM is very high. So this is the relation with reference to bipolar transistor, delta T equal to CL divided by GM. So if GM is increased with the help of using bipolar transistors, so the delay value is decreased. That is the idea behind this. We'll see whether this circuit works as inverter or not. Right? So first of all, to check out that one, I am applying input a logic one. Logic one means VDD voltage I am applying. So when the input is VDD, what I means, the transistor T1 and T2 are in on state. The transistor T1 and T2 are in on state. So whereas P1, the P1 goes to off state. P1 goes to off state. Okay. And if you observe, the transistor N1 drives the base of transistor Q1. Since it is in on state, the transistor Q1 goes to half state. The transistor goes to T1, Q1 goes to half state, right? Because its base is grounded through N1 transistor. Let us see, whereas there is another transistor, the base of transistor Q1 is grounded through N3 transistor. Is it on or off? That we will check. So since the transistor N2 is in on state, it switches on the transistor Q2 because it drives the base of transistor Q2. Okay, so it switches on. Q2 is switches on now, whereas Q1 is switches off. Okay, so with reference to this, since the voltage, since the gate of transistor N3 is also grounded through N1 transistor, it is also goes to half state. It is also goes to half state, right? Remember, in the input is VDD, Q1 is on, Q2 is on, P1 is half, N3 is half, Q1 is half, but Q2 is in on state. Hence the output voltage is a short circuited voltage across Q2 and it is equal to 0, very low voltage. That is treated as a logic 0. So output is complement of the input. Input is logic 1, output is logic 0. Let us see the another case. Now the input is logic 0. With 0 input, what happens? See, the transistor N1 goes to half state. Transistor N2 also half state. Okay. So since N2 is in half, no base current for the transistor Q2. So therefore it is also goes to half state. Check whether Q1 goes to on or not. Since P1 is on, it drives the base of transistor Q1. So it becomes on. It becomes on. And at the same time Q3 also becomes on. Sorry, N3 also becomes on. N3 also becomes on. Okay. So therefore now the transistor Q1 is in on, whereas Q2 is in half. The output voltage is a open circuited voltage. A open circuited voltage, that is VDD, that is treated as a logic 1. So output is definitely complement of the input. So it works as a inverter. And because of bipolar transistors, at the output stage, more amount of current it supplies to charge the capacitor. So like that we can improve the speed, or you can reduce the delay. So that is the BiCMOS inverter. Okay. Now also see the characteristic curve with reference to BiCMOS and CMOS inverters. These are the characteristics represented here. The upper one is the inverter characteristics of CMOS inverter, whereas the lower curve represents characteristics of BiCMOS inverter. Okay, and this is the diagram comparing the delays of CMOS and BiCMOS with reference to load capacitance. At very low capacitances case, the CMOS technology is better, where the delay is very less. But with the incremental of the load capacitance, the BiCMOS inverters or BiCMOS circuits are better because the delay is less. Okay. And in the next class, you can see that is what are the different types of logics available to realize the gates. Okay. Thank you.